Inverse trig functions with the unit circle. Okay, so we have sine of -1 or we have arc sine. These are exactly the same thing. Now, the weird thing about the inverse trig functions is that your result is going to be an angle. With the regular trig function, sine, you plug the angle into it. Okay, so it does the opposite. So this would be like the regular trig function, and this right here would be the opposite of the trig function. So what goes inside? What goes inside here are the coordinates or the sides of the triangle. So, like, for example, what you would find inside of a sine inverse would be 1/2. And so what you have to do for sine inverse, you have to look for the coordinates that have a 1/2. Now this gets kind of tricky because there's a special domain for sine inverse. See, I see a 1/2 right there, and I see a 1/2 right there for the y values because it's a sine inverse. There's no other angle that has those coordinates. Here's the angle, here's the angle. So which is your answer? Is it both or is it just one of them? The answer is it's just one of them. Now for sine inverse, you will not find answers in either of these quadrants because those are not in the domain of sine inverse. The only answers or the only angles that are in the domain of sine inverse are these ones and these ones. Actually, it's not these ones, but it's a negative representation of these. So this one would be -π/6. This one would be -π/4, and this one would be -π/3. So it's these guys right here. These from from π/2 to -π/2 is not this guy, -π/2. Those are the domain numbers for sine inverse. So I should circle that too because I circled all the domain numbers. This is the domain of sine inverse. And so, oh, I'm sorry, I'm saying the wrong word, not domain. These are the range. These are the range numbers for sine inverse. What I'm going to highlight are the domain numbers of sine inverse. So all these y values right here are the domain numbers of sine inverse. So these are the only numbers that you will see plugged into sine inverse, and then what's circled, those are the only results you can get from sine inverse. So look at this. What is sine inverse of 1/2? It would just be π/6. So your answer for this would be π/6. The hardest ones are not cosine inverse, tangent inverse. So you can have arc tangent or you can have tangent inverse. Most people like to write tangent inverse instead. Where the heck is that? Where is tangent inverse for that? And then for cosine inverse, I guess I should talk about cosine inverse too, because this one also has a different domain and range than the sine function. So sine or cosine inverse. So let's first talk about tangent inverse, since tangent inverse has the same domain and range as sine inverse. And so for tangent inverse, where would we get a positive side and we would get rad 3? So your question is, where would I get rad 3 if I were to divide the y and the x? Okay, so if I'm getting rad 3, that's definitely not going to be these coordinates right here. And we can rule out all these coordinates because one of these coordinates is negative, and so you would get a negative result when you divide them. So it's got to be this one or this one. Which one is it going to be? Let's find out. For this one, let's go 1/2 divided by or times 2 over rad 3. So it's technically divided by, so I'm just multiplying by the reciprocal of that guy, and these would cancel out. I would get 1 over rad 3. If I do this one right here, that would be rad 3 over 2, and I multiply by the reciprocal, it would be 2 over 1, and these cancel out, become 1. I get rad 3. All right, there you go. There's our answer. This is our answer for this one. It's π/3. This would be π/3. Now, what about our cosine inverse? Why is he different? He's different because his domain and range are totally different than the sine inverse and the tangent inverse. For cosine, your domain numbers would be this x value, this x value, this x value, this x value. I gotta include that guy. This x value, this x value, this x value, and this x value. So all of those x values in the coordinates would be your domain for cosine inverse. What does that mean? That means those would be the only numbers you could plug into this. So like if I plugged in negative rad 3 over 2, this makes sense. All right, what would my angle be? What would my theta be if I plugged in that? And my results, my range numbers, would be these angles. So the angles in quadrant 1 and 2 are the only angles that you can get for the answers to a cosine inverse function. So negative rad 3 over 2 would be 5 pi over 6. That would be my answer. And you're done with that. So those are your inverse trig functions. We have sine inverse, tangent inverse, and cosine inverse. And also all these can be written with the arc instead. So it can be arc cosine, and then you can plug that into it. Or you can arc tangent, but I don't think that's that confusing. Arc tangent of rad 3 over 2 would equal pi over 3. And I guess I should say this one last thing. Like if you had cosine of sine inverse of, we'll stick with 1/2 since we already talked about him, what would this equal? This would give you, your result is going to be a theta. So this can happen. We just need to find this theta, and then we just find the cosine of that theta. So we would look at 1/2. Now remember, the range for the range and the domain for sine inverse are going to be in the quadrant 1 and quadrant 4. So we look at positive 1/2, which is right here. Our answer is going to be pi over 6. So when we write that out, it'll be cosine of pi over 6. Now I look at pi over 6, and we look at the x value at pi over 6. We get rad 3 over 2, and that is your answer.